Greetings everyone, and welcome to my channel. In this video we are diving headfirst into captivating world of genetics. Our mission today is to craft virtual DNA sequences, and you might be wondering why we are doing this. As we journey deeper into the realm of science, we often find ourselves in need of DNA sequences for a variety of tasks, whether it's for simulating genetic experiments or fine-tuning algorithms. The availability of these virtual DNA sequences is an invaluable asset. We are going to achieve this by using the versatile Python programming language. By the end of this video, we will not only understand the code behind it, but also gain the ability to create your own virtual DNA sequences for any scientific or coding project. Before we delve into the code, let's briefly understand what DNA is. Deoxyribonucleic acid, or DNA, is the genetic blueprint of life. It carries the instructions that dictate the traits and characteristics of all living organisms. DNA is composed of four fundamental building blocks: adenine, guanine, cytosine, and thymine. Now let's dive into the code. We will start by importing essential tools, define functions, and meticulously dissect each line of code. Don't worry if you are new to coding, we will guide you every step of the way. Firstly, we import the choice function from the random module. We are importing the choice function from the random module. This function allows us to randomly select elements from a list. And then let's define a function named generate that creates DNA sequences. And then let's define the possible DNA bases, which are A, G, C, and T. Now let's use a list comprehension to randomly choose bases and create a sequence of the specified length. And then let's join the list of bases to form a complex DNA sequence. As if we don't do this step, every nucleotide will be alone in a different string in our list. And now let's return the generated DNA sequence by using return. Let's try to print our sequence. So print, generate, and then 10. As you can see, we got a DNA sequence composed of 10 nucleotides because we put the length of the nucleotide equal to 10. But what if we want to generate a sequence of 50 nucleotides? In this case, we have to put 50 instead of 10 as our length. 50. As you can see, we got a DNA sequence of 50 nucleotides. In this section, we define a Python function named generate that creates DNA sequences. It takes one argument length, which defaults to 10 if not provided. We define the possible DNA bases as a list containing AGCT. These represent the four nucleotide bases found in DNA. Then by using list comprehension, we generate a DNA sequence of the specified length. We do this by repeatedly selecting random bases from the bases list and creating a list of these bases. We then join this list of bases into a single string to form a complete DNA sequence. But what if we want to produce 50 strings? Every string composed of from 60 to 65 different nucleotides. In this case, we have to use randint function from the random module. From random, import randint. And then we generate a list of random sequence lengths, ranging from 60 to 65 nucleotides, using list comprehension. Length equal to rand int 60 to 65 for I in range 50 to produce 50 different strings. We create a list called length using list comprehension. This list contains 50 random sequence lengths, each ranging from 60 to 65 nucleotides. The rand_int function generates random integers between 60 to 65. Now let's generate DNA sequences based on the random lengths using the generate function. So sequences equal to generate length for length in lengths. And now let's print our sequences. Print. As you can see, we got 50 strings, every string composed of from 60 to 65 different nucleotides. Every string is different and unique. Thanks for watching. I hope you enjoyed the video. If yes, then please don't forget to subscribe to our channel, hit the like button, share the video, and leave your comment under the comment section. Until next time, happy analyzing.